Hello, Algebra 2 students. This will be your last set of notes for Algebra 2. We'll do this. We'll work on this today and tomorrow. And then we will review on Monday, test on Tuesday. And that will be your last grades for Algebra 2. So this is called You Have the Power, and it deals with the relationship between exponential functions, logarithmic functions, and equations. How can we solve these? Do you remember we had, when we solved exponentials before, we did right with the same base? So if I had like 3 to the power of x equals 9, then I could write that as 3 squared, change the 9 to 3 squared, and make that x equals 2. Or if they already had the same base, like 5 to the power of x equals 5 to the power of x, or let's say this was, make this 2x and make this 6. Then you would just set the exponents equal and solve. But sometimes you have equations where you cannot write it with the same base. Look at these four. 2 to the power of x equals 20, 10 to the power of x equals 48, 8.8 to the power of x equals 4, and 2.718, which is our e to the power of x equals 60. What do these equations have in common? You might notice that all of the variables in the exponent. You might also notice that we can't write these with the same base. There's no way to write 20 as a power of 2. There's no way to write 48 as a power of 10. There's no way to write 4 as a power of 0.8. No way to write 60 as a power of 2.718. Number 2 says to solve these equations for x, rewrite each in logarithmic form. Remember, when you do that, this base goes here. That's the subscript. The goal of a logarithm is to isolate the exponent. So then this 20 would have to go here. For b, you've got log base 10 of 48 equals x. Remember, the goal of a logarithm is to isolate the exponent. Now, we normally would not see this 10 written because that's called a common logarithm. The base is understood to be 10. For letter C, we have 0.8 to the power of redo. Part C, what's the base? The base is 0.8. The argument is 4. The exponent is x. The argument is just that number. This one, the base is 2.718, or e. The argument is 60, and the exponent is x. Which of these four equations could be solved directly with a common logarithm? This means the base is 10, and it would be that one. Okay. Common logarithm function on a calculator can evaluate logarithms in base 10. Now, you will see that your waiting for that to go away. Okay. Most calculators, your log calculator, if your phone has a scientific calculator, that log function, Desmos scientific calculator, that log function, older graphing calculators, that log function can only evaluate logs in base 10, or our common logs. Newer graphing calculators, the TI Inspire, actually the Desmos graphing, and some other newer calculators will evaluate logs in any other base. So we're just going to eliminate that. Okay. How can problems involving exponential equations be solved using common logarithms? This is helpful, one, if you don't have a calculator that's going to do that kind of log with the base that's other than 10, or two, if your exponential equation can't be written with the same base. This is another way you can solve this. Now, we can do it by graphing, but sometimes it's hard to find exactly where that intersection is, or you might not have a graphing calculator handy. So the way to do this is first take the log of both sides. So this is going to be log 2 to the power of x equals log 20. The next step says the rule, the exponents on the argument are the same as the power times the logarithm. Remember from our properties that this exponent goes to the front, and now it's x times log 2 equals log 20. Okay? Now, what is my goal here? I'm trying to solve for x. I want to get the x by itself, or isolate that variable. Right now, that x is multiplied by log 2. How do I get rid of multiplied by log 2? Divide by log 2. These cancel, and now have x equals log 20 divided by log 2. Then you would put that in your calculator. Then you could use your phone calculator. If you rotate it, has a scientific calculator, that you can use. You could use Desmos Scientific, whatever calculator, and do log 20 divided by log 2. And we get 4.32192.8. Depending on what problem it is, it'll tell you what to round to. If you wanted to check this, it's not required, but if you wanted to, you could raise 2 to the power of 4.32192.8, and you would get 20. Now, that's probably going to be close. In fact, you'll see this written as approximately, because somewhere we rounded that decimal. So this might come out exactly 20, but it's going to be very close. Approximately 20. Okay, let's try this one. Log both sides. So log of 0.8 to the power of x equals log 4. Move the x to the front. X times log 0.8 equals log 4. Divide. X equals log 4 divided by log 0.8. Which gives you negative 6.21567. If you wanted to check it, you would plug that, what we got in for x, and you would get approximately 4. So what did we do? We logged both sides, moved the exponent to the front, divided, we got our answer. Okay, let's keep going. We have 4 problems here. It says for each exponential equation below, A, rewrite in logarithmic form, B, solve the original equation algebraically, C, evaluate the solution using the calculator. So let's look at this A. So number 5. If I want to rewrite that, remember that base in a logarithm is the subscript. Here we go. So you'd have log base 6 of 104 equals x. The goal of a logarithm is to isolate the exponent. So move the exponent to the other side of the equals. That's if you wanted to rewrite it. Now, if you're using a calculator that will evaluate these logs with a different base, you could go from there. Type in log 6, 104, and you've got your answer. The other way to do this is to log both sides. So if this side of the equal sign, this side of the equal sign, move the exponent to the front, divide. Okay. And log 104 divided by log 6, 2.592. What did we end up doing? We end up taking the log of this number and dividing it by the log of this number. When do we do this? When you have that variable in the exponent and you can't write them with the same base. You can't write 104 as a power of 6 because it turns out it is 6 to the power of 2.592. Okay, let's move over to number 6. If we're going to rewrite this one as logarithm, we would do the base is 1.5. The argument is 22, and the exponent is x. Remember, the goal of a logarithm is to isolate the exponent. If we're going to log both sides, we're going to do log 1.5 raised to the power of x. It doesn't like me to put my little decimal point there. Equals log 22. Move the x to the front. Divide. And get 7.623. Okay. When you have an exponential equation that you can't write with the same base, one way to solve it is to log both sides, move the exponent to the front, and divide. Number 7. We're going to do the same thing. If we're going to rewrite this one, what's the base? The base is 8. The argument is 1200, and the exponent is x. What's the goal of a logarithm? You got it. Isolate the exponent. Okay, here we go. Log both sides. Move the variable to the front. Oops, I forgot my log. Divide. And 3.4096. One more. This one, they took away some of that middle part, some of the structure they have there for you. If we're going to rewrite this one as logarithm, it is log base 7 of 3.5 equals x. Yeah, she's going to say it one more time. The goal of a logarithm is to isolate the exponent. We want to log both sides. Some of you are going to have figured out the pattern by now. We're going to end up taking this log 3.5 and dividing it by log 7. Okay, if you need to, write it out, do that. So log 7 to the power of x equals log 3.5. Move your x to the front. When you divide that one, you get 0.64379. Okay. All right. It says for each solution given above, look at the expressions in the boxes. How are they related? They all have a variable in the exponent. Okay. You're always going to divide by the one that has the base in it. Log 1200 divided by log 8. Log 3.5 divided by log 7. We're dividing by the one that's the base. Log 104 divided by log 6. Log 22 divided by log 1.5. Okay. Change of base property. With a calculator, use the change of base property to evaluate each expression. If we were taking this one, you're going to divide by that base. Okay. This would be the same thing as if we had log base b of n equals x. We do b to the power of x equals n, log both sides, move the x to the front, and divide. So here, you're going to do log 32 divided by log 8. You divide by, the base goes on the bottom. Okay, the base goes on the bottom. So then you would type that in your calculator and get your decimal. Okay, or your fraction. Here, the base goes on the bottom. Here, the base goes on the bottom. And here, the base goes where? In the bottom. I don't know why I made that little 16 there. And then you would just type those in your calculators and get the decimals. Okay? All right. Next. The change of base property log B of n can be rewritten using common logarithms using log n divided by log b. Rewrite each expression below using only common logarithms. The reason for doing this is if in our older calculators you could only do base 10. If you're using a certain calculator that only has base 10, that's the reason of rewriting this. This also makes it easier to solve. So remember, the base goes on the bottom. 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 Oops. It should be log x plus 6, and it should be log 1/2. All right, the good news is we're going to skip all this graphing part. Now, this is your assignment, and you have today and tomorrow to complete this. You're going to use that change of base property, and you can use Desmos Scientific or you can use Desmos Graphing, either way, to find it. So what are you going to do? Remember, the base goes in the bottom. So you have, for example, this log 14 goes in the bottom. Log 91 goes on the top. Use your calculator, get the decimal, okay? So that one turns out to be 1.7. Okay. If you have anything, you want to isolate that base and power first. Like, for example, in number 26, you would divide both sides by 65 first, and then follow that change of base formula. In 27, you would subtract the 80, then divide by 50, and then go to our change of base. All right, you got today and tomorrow to finish these. The only thing left you have to after this next week is a review and a test, and we're done. Have a wonderful day. We'll talk to you later.